In three-dimensional figures, cylinder is one important figure that comes along. It's an object. A cylinder looks like this. This is the diameter. This is the height. We know that diameter is 2 times the radius. So if I draw a radius over here, that goes something like this. So this is the radius, and the other length, let me make it a bit thicker. This red length, that is the height. Now, when we talk about volume of a cylinder, the formula is pi r square into h. And it's something very, very basic. Pi r square, that is the area of circle. And h is the height, or we can also call it the length if the figure is lying down. That means volume is basically the area of cross section multiplied with height, because technically it's a prism. A cylinder is a circular prism, and the volume of a prism is cross-sectional area. So cross-sectional area multiplying with the height or the length. Now, what else is there? If we look at this figure, which looks really, really big, so let me make it smaller. And if we are talking about a solid cylinder, solid or closed cylinder, then we have a top area, we have a bottom area, and we have a curved surface area. Now, curved surface, let me write it like this. Now, when we talk about the volume, it doesn't make a difference whether I'm talking about closed cylinder, I'm talking about a solid cylinder, I'm talking about an open cylinder, volume remain fixed. When I talk about a solid closed cylinder, I'm specifically talking about these things. The top is a circle. So the top is a circle. So is the bottom. That's also a circle. And the curved surface area, that is basically a rectangle. Now, this looks kind of not making any sense. How is this curved surface area a rectangle? Now, let me explain it using the soup can. Again, making the figure a bit smaller. This is the soup can. And there is this label on it, the soup label. It's wrapping around the cylinder. That means when I open this up, we will get a rectangle. Now, this is the base areas. Let me make another key. And let me write, this is the top area. And then let me write the base area. So top and base is the same. And the lateral area, which is also known as the curved surface area. Now look at this. If I open this out, what do I get? When I open this out, I get a rectangle like this. Now this thing, for this rectangle, this is the circumference. So this circumference is 2 pi r, and this thing is the height. So this is h over here, like this. And this is 2 pi r, that is the length. So therefore, the area of rectangle is 2 pi r h. So therefore, going back over here, we have the top area, that is pi r square. We have the bottom area, that is pi r square. We have the curved surface area, that's a rectangle. Reference is the soup label. That is how we got this idea. That is 2 pi r h. So now if it's a solid or a closed cylinder, so let me make a big thing over here. And let me write it like this. So the total surface area is pi r square plus pi r square plus 2 pi r h, which comes out to be 2 pi r square plus 2 pi r h. This is for a solid closed cylinder. What if we have a cylinder? I'm not sure whether I have that diagram or not. Let me just draw another one. And let me just write down the cylinder over here. Let me make it smaller. Now, let's say this is an open cylindrical can. And since it's open, we only have the base. Let me just make it like this. Now, this is the base. And this base has an area of pi r square. And then this is the curved surface area. That equals to 2 pi r h. And there is no area at the top. Why? Because it's an open cylindrical can. So therefore, the total surface area is only the base area plus the curved surface area, which is pi r square plus 2 pi r h. So now let's summarize everything that we have learned so far. The total surface area for a solid versus an open. So let's write everything down in one place. And let me draw a box over here. So therefore, this is for a cylinder. Two categories. There is the closed or solid cylinder versus there is an open cylinder. What is the same? The volume is the same. Volume for this versus volume for this is the same. V is pi r square h. V is pi r square h. That's exactly the same. What about the base area? Actually, we can start with the top. The curved surface area, that's also the same. This is 2 pi r h. This is 2 pi r h. This is curved surface area. This is curved surface area. What about the base area? That's also the same. The base area is pi r square. The base area is pi r square. What about the top area? In open, it's NA, which means not applicable, does not exist. There is no top. Why? Because it's open. What about the top area over here? That is pi r square. So therefore, when I add this and this and this, therefore total surface area is 2 pi r square plus 2 pi r h. Whereas over here, we have curved surface area, we have base area does not exist. So total surface area is pi r square plus 2 pi r h. Now the whole thing which makes mensuration difficult is the formulas. So as you can see, I'm focusing very, very heavily on how these formulas came into being, which part represents which part exactly. And that is why too much focus is there on the formulas. And I have summarized it for everything that we've studied so far. So now let's look at this question, just go through it. And then we can get started with this. Now the question says, a closed cylindrical can is 11 centimeters high and a base has a diameter of 7. That means this looks like a paper 2 question to me. Yes, it is paper 2. The radius is equals to 3.5 centimeters. Calculate the volume of the tin. First part, volume is pi r square, which is 3.5 square into h, which is 11. And you use a calculator, you use the 4 significant figure value. So let me highlight it over here. Pi, we use 3.142. Do not use the calculator value. This is already given to 4 significant figures. So let me grab my calculator. And this is 3.142 into 3.5 square into 11. So 3.5 into 3.5 into 3.142 into 11. This comes out to be 423.38. Let's round it off to 3 SF. That is 423 centimeters square. Just write 3 SF over here. Calculate the total external surface area. So we are interested in total external surface area of the tin. Now keep in mind, it's a closed cylindrical tin. So yes, there is a top, there is a bottom, there is the curved surface area. So just use the formula. Total surface area is 2 pi r square plus 2 pi r h. I can use a little bit of simplification. Let me take 2 pi r common. We are left with r over here. We are left with h over here. So that will reduce my work. First simplify, then plug in the values. So part 2 continued. This is 2 into 3.142 into 3.5, and this is 3.5 plus 11. So 2 into 3.5 is 7. 7 into 3.142. This comes out to be 21.994 exact value based upon 4SF, and 3.5 plus 11 is 14.5. Multiply it with 14.5. This comes out to be 318.913 centimeters square. And this comes out to be 319 because after the rounding off. So this is 319 and centimeters square. Now it says, in addition to the surface area, a closed tin requires an extra 30 centimeters square of metal to allow the top, bottom, and side to be joined together. Calculate the area of metal required for 30,000 closed tins. Give your answer in square meters. This is everyday math. So basically, for part 3, use unrounded value 318.913 plus 30. That is the total surface area. So 318 plus 30, that is 348.913. Now take this 348.913, multiply it with 30,000. Let me multiply 348.913 into 30,000. This comes out to be 10467390. This is centimeter square. We want the answer in square meters. Now let's play with the conversion. 100 centimeters equals to 1 meter. Square both sides. When we square both sides, we have 1, 2, 3, 4 centimeters square. That equals to 1 meter square. Therefore, 10467390 centimeter square is x meter square. Now look at the ratio. 1, 2, 3, 4. 4 zeros is becoming 1. Therefore, this answer will be divided by 4 zeros. So 1, 2, 3, and 4. This is 1046.7390 meters square. But we want the answer. Give your answer in square meters. So this is our answer in square meters. Now this is the question that's related to cylinder. Let's also focus on this question. This is again a paper 2 question. Just go through it once, and then I'll get started with this. Now the question says, solid 1 is a cylinder. It's a big question. We are only doing A part 1 right now. Solid 1 is a cylinder with a small cylinder removed from its center. So this is solid 1. This cylinder has been removed. So let me just highlight this. So over here, this thing and this thing is removed like this. This cylinder over here, this is removed. The same goes over here. Like this. This thing has been removed. Now it says the height of each cylinder is 20. So the height of both the cylinder is 20. Radius of the small cylinder is R. This is R. This gap is 3.5. The radius of the large cylinder is 3.5 greater than the radius of the small cylinder. The volume of the solid is 3000. Calculate R. That means if we are talking about volume of large minus volume of small, that is volume of the solid one. Is that so? If this was a complete wooden cylinder, that's the volume of this big one minus the volume that has been removed. That will give you the volume of the solid. Radius of small cylinder is R. Radius of big cylinder is R plus 3.5. This is R. Hold for a second. You go back. This is R and then this is 3.5. Volume of large, that is pi, and this is R plus 3.5 square into H, which is 20. This is volume of large. Minus volume of small, that is pi, this is R square, and this is 20. This equals to 3000. Now, what should I take common? Let me take pi common. Let me take 20 common. Pi common. 20 common. Therefore, pi common, 20 common, bracket closed, equals to 3000 over here. What's inside the bracket? R plus 3.5 square minus R square. And let me just grab it closer to this. So now, R square plus 2 into R into 3.5 plus 3.5 square. This is just this much. And then we have this negative sign and then R square. So we have this negative sign and then R square, negative and R square. and bracket closed. This equals to 3000 over 20 pi. So therefore, this r square gets cancelled out. 2 into 3.5 is 7. This is 7r. This is plus 3.5 square equals to 3000 over 20. The zeros cancel. 2 ones are 2 into 150. 150 divided by 3.142. So 150 divided by 3.142. This comes out to be 47.740. 47.740 r into 7. And this is 3.5 into 3.5. That is 12.25 is 47.740. 7r is 47.740 minus 12.25. Therefore, r is 47.740 minus 12.25 divided by 7. First, we will write the 4SF value. Then we will write the 3SF value. So let me do the subtraction. 47.740 minus 12.25 divided by 7. This comes out to be 5.07 exactly. Actually, it's just giving me the exact answer right away without any approximation. So that is the value of R. And 5.06 to 5.08. So I'm getting this exact value because this is the value that I've used for pi. Remember, we use pi as 3.142 correct to 4 significant figure. So that all worked out for me. That completes the concept of cylinders.